Hello. In the last video, I motivated the use of files by saying that, well, it can really accelerate your development if you take your simulation and you split it into two parts, where you have the first part is the heavy computation, and then you write those results to a file, and the second part you load the results and then you do the analysis and the plotting. Now, it actually goes way beyond that. You need to know how to read data from files, because that's how you often get data into your program. And you need to know how to write your data to files, because that's how you persist data. That's how you can share your results with other people. So in that video, we began the first step, which was to get a handle on our file system, and that's what the pathlib package is for. In this video, we're going to do the second part, and I'm going to describe to you different formats or different ways of writing data of various types into files of different formats. So let's get started. This table summarizes the 5 different approaches to reading and writing files that we'll cover in this video. Now, which one you use will depend on what type of data you're working with and what type of file that you wish to create. That will determine the approach that you use. Now, we'll describe all of them in detail in the video. For now, let's just summarize. So, if you are working with arbitrary text, just strings, and you want to create a text file, that is one that you can open and read with a text editor, then Python has these built-in methods: open, read, and write. If you're working just with other native Python types, so your dictionary, tuple, list, etc., and you want to write those to a binary file. So a binary file is consists of zeros and ones, and so it's not readable in a text editor. Well, Python has a package called Pickle. Now, Pickle is nice because it's part of the standard library. So this package comes out of the box with Python. And so if you are sharing your data, if you send this file to someone else, then they won't have to install some third-party package in order to read your data. Now, if you're working with numbers, that is with NumPy arrays, you have two options. You can save to a binary file or save to a text file. For binary file, that's a little bit maybe more compressed, not readable with the text editor. Then you have save, save-z, and load. And for text files, we use load text and save text. Finally, if you have tabular data, so tabular data is like a table, and this sort of data shows up a lot in say, data science. You can save this to a text file using Python's CSV package. CSV stands for comma-separated values, so these are, each column will be separated by a comma or whatever delimiter that you choose. This is also part of the standard library. So that's nice. But here I want to recommend a third-party package that has become ubiquitous in, say, data science and where people work a lot with tabular data, and that is the Pandas library. So I would say that Pandas is really useful if you're working with tabular data, and if you find that yourself in that situation, go and try to learn Pandas after you finish with this course. Okay, well, let's get started with the details. We'll begin with writing arbitrary text to a text file. And this is some boilerplate code that we use to demonstrate the concept. Now, it begins with defining an output file. And in this case, I want to write to a file called write_text.txt. And that file will be located in a temp folder in my home directory. So the actual writing of the file occurs here in this paragraph of code, and you see that it begins with this very interesting line, with open out file w as f. Now, this has several things that we've never encountered before. It has two keywords, with and as, that we have not seen before, and this function open. So let's take a little time and just understand this. To begin with the function, open out file w. So this takes the name of the file and also a mode in which we want to open that file. And in this case, we're opening it in write mode. That's the W. And we'll see the other modes in a second. So what this is saying is that we want to open this file in write mode, and we want to refer to the object that points to that file as F. And so this whole thing is saying, open the file in write mode, give me an object F, and that F will be valid within this clause that is indented with respect to the width. And then once we're done with these lines of code, then outside of this with clause, well, F will disappear and Python will take care of nicely closing the file for you. So that's a very convenient syntax. Now, while the file is open, that is in here, we have this function or this method write attached to the F object. And when we call write and we pass in just any arbitrary string, it will write that string to the file. So that's how we write arbitrary text to text files. Let's see this in action. So here I have the same code that I showed you in the previous slide. I've now saved it to a file called filesWriteText.py. Underneath I have a terminal where I can execute that file. I say Python and then I give the name of the file. Okay, and so as soon as I press enter here, it will run this code. Hopefully it will create this file, write text, and it will write those lines to it. So on the right here, I have opened that folder. So this is home Gomez temp, and you see that it is currently empty. As soon as I run this, there you go. I have the file. If I open it, I see my 2 lines. Here are some of the different modes that we can use for opening a file. We already saw the W mode. That is open for writing, but keep in mind that this mode will erase the content of the file first. So if that's not what you want, if what you want is to append to the end of an already existing file, then use the A mode, that is open for writing, appending to the end. If what you want is to read from a file, then you use R, and this is the default mode. So if you don't use anything, then it will open for reading. And these 3, by default, are writing to a text format. Later we'll see how you can write to a binary format, and in that case, you want to open it in binary mode. So if you were writing to a binary format, you use WB. If you're reading from a binary format, you use RB. Now I'll show how you can read arbitrary text from a text file. It begins in the same way, defining the file of interest. In this case, it's the same file that I wrote before, writetext.txt. And then we open that file in the same way, except that we're going to open it in the read mode. Once we do that, then within this context, we can call the readLines method on that file object, and that will return a sequence of all of the lines in the file. Then we can iterate through that sequence and get the file line by line. Each line is now a string, which we can process in any way that we like. In this case, I'm simply going to print it. So this is, if you recall, the file had 2 lines. If I run this code, I'm going to run Python filesReadText.py, and it's going to just print my 2 lines. What if we're not working exclusively with strings, but we have in our code other Python data types? Such as in this example, I have this variable x, and it's a list, and the list contains a couple of dictionaries. And then I also have y, which is a string. And let's say I want to store both of these into a file. Now for that, I can use the pickle package, which is part of the standard library. And its use is very similar. So we start by creating the output file, and the standard extension for pickle files is .pickle, but actually you can use whatever you want. And then we open that file in the WB mode, that is in write binary mode. And then once we have the file open, we can use the pickle.dump function, and we pass into it a tuple that has all of the variables that we want to put into that file, and we also pass in the file itself. Okay, so let's run this. This file is called files picklewrite.py. So I'm going to run python files picklewrite.py. And when I run that, you see that it writes the pickle file. Now, if I try to open this, let's try to open it here. It says, I don't know how to open it. It's a bunch of gibberish. So I cannot read this using a regular text editor. But let's see how we read it using Python. So here's the code for reading this in Python. Again, import the pickle package, define the input file, which is pointing at this mydata.pickle, and then we open that file in read binary file, and then we simply call pickle.load on that, and it's going to return our tuple, xy tuple, which we can then just simply unpack, and let's see what x is and what y is. So let's save that and then run this. Okay, so it's returning x and y. X is the exact same list of dictionaries, and y is the string that I defined before. The next situation is when we are working with numbers, that is, we're working with NumPy, and we want to save our data to binary files. In that case, we have two options. We can either use np.save, or we can use np.savez. So the difference between those two is that save is for storing one variable at a time, or one array at a time in a file. So you store each array in a separate file. On the other hand, with savez, you can store many arrays in a single zip file. So this is how it works. We have here some data that we defined. A is a 2D array and B is a 1D array. I can use save. I pass in the name of the file that I want to send it to, which is going to be a.npy stored in my temp directory. And I do the same thing with B. Now, if I wanted to store both of them in a single file, savez, I pass in a name of an npz file. And then I can pass in all of the variables that I want to save. Now, here is something a little bit odd, is that I have to give the name of that variable within that npz file. And so I have no interest in changing the name. So I'm just going to assign A the name A and B the name B. Now, if I wanted to have something different, I could say something like B1, and then within this file, B would show up as B1. So let's do that just for demonstration purposes. And now I'll run this file. So I'll say Python, it's called files numpy save.py. I run it, and now it's created 3 files. These first 2 are the npy files created by save, and you can see that they are binary files. The third one, mydata.npz, is a zip file, and if I double click on it to extract it, we can see that it contains 2 npy files called A1 and B1. So now I'm going to show you how you can read this information back into a Python program. Loading binary NumPy data into Python is very simple. You just use the np.load function, and that works whether the file is an npy file or a zipped npz file. So that function takes, as you might imagine, the path to the data, to the file that you want to load, and if it's an npy file with a single array in it, it will just return the array. If it is a zipped file with multiple arrays in it, then it's going to return this dictionary-like structure that you can then query to get out each array. So the key for that dictionary will be the name that we associated with a particular array. And so, well, in this case, A, if it's loading correctly, A should be the same as A1, and B should be the same as B1. So let's see if this is working correctly. I'm going to print A here, and I'm going to print B, and, well, let's just run that. So I'm going to say Python files numpy load.py, and there we have A and B. Very good. What about A1 and B1? If I Now print those. Yes, I get A1 is the same as A, and B1 is the same as B. So it's working correctly. We can also save our NumPy arrays to human-readable text files rather than binary files. And for that, we use np.savetxt instead of np.save. Now, savetxt is similar to save in that you can only store a single array in each file. And there's no equivalent to saveZ for text files. But the syntax is similar. We pass in the name of the file and the array that we wish to store, and that should save that array to this file. So let's try that out. I'm going to say Python files numpy save text, and that creates this text file, the CSV file. So let's open that. We see that we have the array here. It has 2 rows and 3 columns. The format for the numbers is very verbose, right? We might want to control the format that it's written in, and we can do that, but we won't do that here. Another thing to notice is that it's separating the numbers using a space. Now, often we like to use commas to separate numbers. Indeed, CSV stands for comma-separated values. And we can do that. We can set the delimiter by passing in delimiter, the delimiter keyword, and setting it to whatever character we wish to use as the delimiter. So let's run that. Run it again. And now we see that the delimiter is set to a comma. Okay, now loading text files into NumPy is also very simple. We just use the np.loadtxt function. And to this, we just need to pass in the name of the file, and that will load the array and assign it to whatever variable we give it. Now, in this case, because I have changed the delimiter from the default space to a comma, I better tell the loader that as well, what delimiter to expect. So now the delimiter is set to comma, and let's see if it loads it correctly. So I'm going to say Python files numpy load txt, and yes, it loads the A matrix correctly. So as you can see, it's very simple to work with text files when we're in NumPy. Finally, we have tabular data. So a table is a very specific type of data structure where you may have a header row, and then it's followed by several rows, and then you have columns as well. And each column may have a different data type to it. So in this case, you have a first column that are strings, second column are floats, and third column is integers. And so let's say that you have encoded this tabular information in the way that I'm showing here. This is a list of lists. Okay, how do we write this to a file? Well, we can use this CSV package. That is part of the standard library. And the way it works is very similar to the built-in open read-write methods that we used for arbitrary text. We create our output file, we open it in write mode, and then we create, from the CSV package, we create a writer, and we pass in the file handler for the writer. That gives us a writer, and it gives us a method called write rows, and we can directly pass this list of lists into write rows, and it will write our CSV file. So let's do that. I'm going to say Python files CSV write, and it creates here a table file. If I open that, I see that it's a very simply formatted table. Okay, how can we read this back into Python? Well, again, we use the CSV package. Again, we create our file, and this time we open it in read mode. And now we can get a CSV reader, which is similar to read lines from before. It's going to give us a sequence of lines from the CSV, and those lines are going to be in the form of lists. So if I printed out here the type of the line, I'm going to run this, Python files CSV read. Okay, these are all lists. The lines are lists. So what do they look like? Okay, so each line is a list with 3 strings in it. So we can unpack those. I can say name, height, and age is going to be my line. And then I will have unpacked these 3 things. Now I want to add these as rows to the table. So I have an empty list for my table. I can append the name, a list which is going to be the name, the height, and the age. Let's see what we get from that. Oh, I should print the table. Okay, so now we have list of lists. The first row is a little bit different because it's the header. And I also want to cast these into their appropriate type. So I would like to cast the height as a float and the age as an integer. But I have to be careful not to do it for the first row. That will give me an error because this string height, which is the header, cannot be cast as a float. So let's make sure that we're not doing the casting for the very first row. Now for that, I would like to detect the first row. So I'm going to put an enumerate here, and that's going to give me the counter for the row. Okay, and so if the row is the first row, then I am just going to append things without casting, and if otherwise, I'm going to append things with casting. So here I'll just put height and age, and well, let's see what happens there. Okay, so that works well. Now we have the table in the exact same format as before, with a first row that has the name, height, and age, the second row which has a string, a float, and an integer, and the third and fourth as well. So that's tables in Python. Well, that does it for files, reading and writing to files in Python, and it does it for this module. I'll see you in the next one.